All right, let's get started. Hey everybody, my name's Don, and I've got this very fancy title up here that I submitted, but really what I'm going to be talking about is Hadoop and Python, right? It's that simple. And really what this talk is, behind the scenes, I'm a very honest person, I like to be upfront. What this talk is about is trying to sell you on why Hadoop and Python is cool, okay? That's what this is about. It's a 40-minute talk, so I'm not going to be able to teach you too much about how to actually do this. I'm going to show you some nuggets of code here and there to show you guys how easy it is and how you can do it. But the overall point of the talk is to give you an overview of how Hadoop works across the ecosystem, HDFS, MapReduce, Spark, different smaller components, and really show you how you can use Hadoop with Python. So I hope that's what you were expecting. All right. So a little bit about me. I wrote I'll talk about that one last. So for the projects that I use, I'm a big Hadoop user. I've been using Hadoop since 2009. I've been using Python since 2002, 2003. Some of the other kind of projects that I'm heavily involved in that I like to use a lot, one is Pig, another one's Accumulo, which I'm not going to be talking about at all. In terms of my work history, I did a stint at Greenplum for a while doing some Hadoop stuff there. I've done a lot of work with a government contractor called ClearEdge, where I did some work for DoD, did some Hadoop architecture there. And then most recently I have my own data science consulting company that I've got a small team of guys that we do consulting work for people. I got my PhD at University of Maryland, Baltimore County, and I live in Maryland, I'm a Ravens fan, all that good stuff, eat crabs. I wrote a book, I'm saving the best for last. I wrote a book called MapReduce Design Patterns, which is about Java MapReduce, which is always kind of funny. Like one of the things that comes up is, hey, why are you such a big proponent of Python and Hadoop? You wrote a book on Java MapReduce, and I don't know. Actually, I'm working on the second edition of MapReduce Design Patterns right now, and one of the things we're adding is mrjob, which is a way which I'll be showing you guys in a second, of how to write MapReduce jobs in Python is going to be included in that book as well. So I'm trying to tie it in a little bit. But anyways, enough about me. So one of the things I do since it's 2015 and we have Google is instead of using clip art, I Google for my clip art now when I do presentations. And when I Googled for elephant and Python and a couple of different things, this is the image that came up. And I haven't seen this image since I was in like 5th grade. And I forget exactly what it's trying to say, but it's something about like the top one looks maybe like a hat and the bottom one's like a snake that ate an elephant or something. I spent like a good hour trying to figure out how I could make an analogy between this and what I was going to talk about, and I kind of gave up, but I still wanted to show you guys the picture for no good reason at all. So what I'm all right, so starting to talk about what I'm really going to talk about. What does Hadoop with Python mean? What I mean is that whatever you're probably doing in Java right now, I would probably like to be doing in Python instead. So you're thinking about writing MapReduce jobs. Maybe I write some coordination stuff with Python and interact with HDFS. Maybe I'm writing some sort of ingest pipeline. Maybe I'm using Spark. Maybe I'm using Storm, whatever. Right? My general premise here, it's not that complicated, is I want to do stuff in Hadoop with Python. And so what this talk is going to be about, it's going to be structured in 3 major phases. I'm going to talk about like what's good about Python with Hadoop, like conceptually what's bad about it, and then try to make some sort of opinionated discussion about when you should use one or the other. I'm going to talk about some of the downfalls. And I'm going to go do a quick like survey of the major projects that you should probably know about and give some sample code for each. And at the end, I'm going to tie it up with like talking about what I think the community as a whole needs to be doing for Python and Hadoop. So first, let's start with the good stuff. And the most obvious one, this is kind of preaching to the choir here, is what's good about Hadoop. Like, why would a Python user want to use Hadoop? And so try to put yourself in these shoes. I've given this talk more often in front of Python audience than Hadoop audiences. So usually this is this is expanded out into 15 or so slides with the Python audience, but I can press it down to 1. So the first is linear scalability. Now, I mean, this may seem obvious now in this day and age, but this is a big deal with Hadoop, right? So I can have my Python MapReduce job, let's say, and I can write it and runs on one node. I can kind of expect it to run on 1,000 nodes. If I ever grow my data, I can expect it to grow more. And I have this like general idea that things are linearly scalable, which is super powerful. The next one is schema and read and unstructured data. So I don't have to load all my data into these nice, pretty schemas. I can kind of deal with data as it comes in and how it is. I can deal with things like raw text, images, all that good stuff. Transparent parallelism is another big one. So a lot of the ways that I do parallelism in Python without Hadoop is not transparent. So if I'm using like a messaging queue, or if I'm dealing with threads or processes, things like that, like I know that I'm writing a parallelized application, right? It's not like I'm just writing this Python program and behind the scenes it's magically getting parallelized. So that's one thing that's really nice about Hadoop, is that it kind of hides all the parallelization, fault tolerance, and all that stuff from the user. The next one is open source, which is, I don't know. Well, I'm not going to spend too much time about why open source is good. I think you guys hear about that enough. But yeah, it's a good thing. So overall, we want to do what a Python user wants to do is there's all this cool stuff that I could be doing with Hadoop in terms of these kind of 4 major points that I laid out here. Well, the first 3 major points is that I want to do those things with Python, and I want to do it in an open source way, and Hadoop's perfect for that, but there's some gaps, then I'm going to talk about those gaps. Okay. So the next one is succinct code, which is in the title. And this is a big reason why I like Hadoop, or Python rather. So this comic is pretty classic. There's also like another like 8 panels or something for other languages, but the Python and Java one, so the guy with the glasses is kind of commenting about how with the Python it seemed like too easy, you just did import, and then with Java I'm 2 pages in and I still have no idea what you're saying. So, I mean, I'll walk into a new customer or something like that, I'll look at some of their MapReduce code, it takes me a good like 15 minutes to figure out what this Java MapReduce program is doing, right? It's just long, right? It's a big piece of code, and it doesn't flow very nicely, and it's just hard to digest. It's almost like you have to read it over and over and over again to really figure out what you're saying. In Python, what I'm really saying is that I think that when you're writing these things in Python, it's easier for me to figure out what the code is saying because it's more succinct, it's a little bit higher level, it's a little bit easier to digest. So the first thing I want to point out is on the bottom right here, on the slides in which I'm stating my personal opinion based on, I don't know, I try to talk a little bit about why I was credible at the beginning of this thing, but I added warning signs about like, okay, this is my opinion now, I'm not like, I haven't performed some sort of research study or anything, right? This is just my personal opinion. If you want to believe me, then good. If you want to argue with me, then come talk to me afterwards, I guess. But don't try to embarrass me in public. So the first one is faster development. So when I sit down and write a Java MapReduce job versus when I sit down and write a Python MapReduce job, or pretty much in every single scenario, if I'm going to do it in Python versus I'm going to do it in Java, doing it in Python is going to be faster. Okay, I'm not making really that's all I'm saying. I'm not saying it's better, I'm not saying it's easier, I'm not saying anything, I'm just saying it's faster, okay? Okay, opinion number 1. Next one is less enterprisey. All right, it's the first time I ever got a clap in the middle of a talk. I'm not exactly sure what I mean by less enterprisey. It's more of a feeling. It's more of about like a sense that I get when I'm writing code. I don't feel like I feel like I'm like in a cafe shop or something. I'm writing code. I don't feel like I'm in like a cube farm. Okay, so what I really mean about enterprisey is that I'm not writing like enterprise code, right? I'm writing code that's, to me, feels, this is a very feeling kind of thing. The code feels like I'm more directly talking to the computer and I'm doing a little bit closer working with my data. Meanwhile, in Java, I'm sitting there thinking like, oh, like, well, I need to create this object and I need to create this like abstract factory, and it, like, so I think there's some advantages here to being less enterprisey. I think the next big one is lower barrier of entry as well. So a lot of universities, for example, have switched to Python as their introductory language for teaching computer science. I think there's a lot of merits. Again, this is opinion, that say that Python maybe is easier to learn. So in some organizations, for example, I've seen it's not necessarily that some of these smart people couldn't learn Java, just they're more scared of it. I think when you have some people like statisticians or data scientists, for example, that don't have a really strong programming background, I've generally seen that these people are more comfortable with Python. So the next big overarching thing that I really like about Python, which I think is undersold a little bit, is that Python naturally is interpreted, and then Java, I guess, is compiled, I guess, kind of. I guess there's a bit nuance there, but okay, so one thing that I really like to do is change code in place. Okay, so like there's probably a lot of people that I work with that hate me for doing this, but I want to SSH into my cluster, edit my Python script, and then rerun it and see how it works, right? Like I want to be interacting with my Hadoop cluster, and I want to be iterating quickly. Like let's take the other side, right? If I'm developing a Java MapReduce job, right? I'm developing it in Eclipse in my local workstation, right? I compile it, I send it, I guess, my jars to the Hadoop cluster. I mean, don't get me wrong, there's plenty of easier ways to do this these days, but this is one way, right? I submit my jars up to the cluster, I run it. Oh, I accidentally have a less than sign than a greater sign. Okay, well, let me go back to Eclipse, change it, recompile it, move it. Like, this seems kind of trivial, but over time, it's one of those things that wears on your soul, and just over time, I just flip out, right? So I think this is something that's convenient for me over time that I really like. This one, again, is opinion. I think continuous integration when I'm just dealing with scripts opposed to like compiled things, right? I don't need some sort of server that's compiling things and making sure it builds and everything. There's pros and cons to this, right? So not everything here is perfect, but I think I've seen in some situations like continuous integration with Python be a little bit at least easier to implement. The other one is more platform portable, which is kind of ridiculous because I think that's why Java was built to begin with, right? So I've seen, for example, like they updated the Hadoop cluster, and then people are still compiling Java on their local workstation, like compiling their Java MapReduce on their local workstation, moving up the jars, and then like the versions of Hadoop are mismatched, and then everything breaks. Like a Python script, on the other hand, you update the interpreter or the libraries underneath. In general, like I feel safer about that. I mean, it's not that I run into this problem a lot with Java, but it definitely makes me feel safer, and the code's a little bit more portable. Again, opinion here. So the next one is Python libraries for data, and so I gave a tutorial on Python and Hadoop at PyCon this past year, a few months ago in Montreal, and likewise that was a Python audience, right? Meanwhile, this I believe is a Hadoop audience, and at PyCon there's a big hype about data and data analysis. So the Python community is really all hyped up about data analysis. So a lot of the tutorials were data related. I think like data web frameworks, for example, are starting to get a little bit more boring, I guess. And people are starting to figure out that data analysis with Python is pretty cool. So I think one of the good things is that Python has a lot of momentum in data analysis right now. And I think one of the good things is that if we did Python with Hadoop, then we could kind of leverage some of that momentum that community has. The next one is tighter integration with data science. I didn't know what to do with this bullet point. I think what I mean here is that a lot of data scientists right now are using Python, and they prefer Python for their non-big data workloads, right? And I'm one of those people. And if I'm doing so kind of one of the things I used to do when I used to do like maybe some of the more machine learning stuff that I like to do in Python, or even this is true argument with R, is that maybe like in 2011-ish, what I would do is I would write a Java MapReduce job that would maybe build my feature vector or something like that. I would output that thing, and then I'd run a Python script over it, right? But with some of the Python Hadoop stuff that exists right now, I can just end-to-end use Python, which is kind of nice. So in a data scientist environment, that's great. It's just more convenient, right? It's not a big deal, but it's convenient. The other thing too is that Python has a lot of like really first-class libraries. So I mean, every language has its own libraries, right? But Python's data analysis libraries are actually really, really good in my opinion. And that's one of the reasons why I stick with Python. Some of these are like pandas, which is a data analysis library that mimics a lot of like R data frames. You got scikit-learn, which is a very comprehensive machine learning library. NLTK is a great natural language processing library. NumPy and SciPy provide a lot of the foundation of fast data structures, matrices, and arrays, things like that. GenSim is a topic modeling framework. Matplotlib is a fantastic plotting library. So these libraries are really great. And in some cases, I like them better, as somebody that's proficient in Java as well, I like them better than the Java counterparts, just as like a functionality, what they're able to do, things like that. So I kind of miss these things. And so when I'm doing Hadoop stuff and I want to be using these two things together, sometimes I have a hard time dealing with that. Okay. All right, so the bads. So here we are, back again at enterprisey. There are some good things about being enterprisey, right? That's why we even got here. Some of the things in particular are when I work on larger teams, for example, where we have shared code, sometimes the enterpriseness of the Java code that we're writing is good for collaboration. Python can get really sloppy. One of my favorite sayings is, I don't know who to attribute it to, but Java lets both really good programmers and really bad programmers write mediocre code. And there's a little bit of truth to that. So basically, it forces everybody, it's pretty strict in what the code that comes out of that. You've got type safety and you've got classes and interfaces and things like that. It makes it so that interacting with the code is pretty straightforward. In Python, it's a little bit looser. So bad programmers can write bad code and good programmers can write good code, and there's also different styles. Like I could write in a more functional style, I can write in a more procedural style. And so with kind of more enterprisey code, when you're sharing code on larger projects, I find that Java may be better because it kind of enforces some things by the nature of the code. Meanwhile, with Python, if you're on a large project, I find that you need to have good coding standards, good code reviews, things like that to compensate. The next one is type safety. So type safety is pretty important in my opinion, especially with dealing with data, because I'm dealing with data, right? I've got is this an integer or is it a string? Or is it a integer encoded as a string? These things get really complicated, and when different pieces of code start passing back and forth, you can run into a lot of issues when you're not being super careful about type safety. Especially in Python, a lot of the Python frameworks, both the normal Python frameworks and the Hadoop ones will make assumptions about data types, automatically converting things to strings or integers, things like that. And that can really lead to some trouble and troubleshooting things that are kind of difficult. The next one is no JVM sandbox safety. So some of the Python on Hadoop libraries will start up a Python interpreter, a CPython interpreter on the outside, and that's outside of JVM land, right? So if you fork a bunch of times or if you take up a bunch of memory, right, there's less safety. So there is something to be said about the JVM in this environment with Hadoop kind of providing that sandbox so that you don't do anything too crazy. I think there's some ways to still solve this problem in Python, but for Java, you kind of get it for free. On the other hand, though, I do like this sometimes, right? Sometimes I don't want the JVM to tell me how much memory I can have and things like that. If I maybe have a little bit more power and I'm competent, then I like to live on the dangerous side a little bit and use all the RAM that I want. The next one is performance. So there's also just the general Python versus Java performance, but then we'll also get into some of the reasons why performance is a big problem in Hadoop and Python. So I think these are kind of the outline of the bad ones, but I only have one bad slide. I had 4 good slides just to keep my bias straight. All right. So to summarize the good and bad, and this is really just trying to say, me personally, if I have both Python and Hadoop and just regular Java Hadoop in the environment where I kind of draw the line, for the most part, when I'm doing data analysis or data science where I almost feel like I'm querying the data, right? I'm sending a query to the data, I'm getting some answers back, maybe I'm iterating a little bit. It's all throwaway code. This is for example, if I was writing SQL at a terminal, right? That's kind of maybe what this feels like. If I'm returning it into some sort of production code or something like that, or if it's a data pipeline, or if it's a ETL process that's writing into Hive, or if it's a ETL process that's writing into some database down the line, or if it's building a report every day, things like that, that's something that I still maybe trust Java MapReduce with a little bit better, mostly because of performance and just kind of maintainability. The one thing, though, that I really want to point out is that the good and the bads that I outlined so far in this talk, they're different strengths for everybody, right? So if you're only doing like ETL jobs in your Hadoop cluster, then maybe I would argue that some of the goods that I outlined are not as important to you, and some of the bads are more important to you, right? So it's very hard for me to say like you should definitely use Python for this problem and you should definitely use Hadoop for this problem, or Python or Java for this problem. So let's talk a little bit about the ugly things here, because there's always the good, bad, and the ugly, right? So first of all, nothing in Hadoop is native in Python. Everything in Hadoop, for the most part, is written in Java. So when you're using Python with Hadoop across the ecosystem here, pretty much nothing is native, meaning that everything has to go through some sort of serialization or translation or some sort of intermediary, and this is the general case. And that's bad for a number of reasons, and we'll talk about that a little bit. The next one is kind of related to that, is that performance can become really, really bad. We'll talk about it a little bit, where because of this non-nativeness, the serialization overhead or the interprocess communication overhead of dealing with this Python interpreter that's side saddling or serializing in between different things, the performance can degrade to like an order of magnitude or to a point where you're like, wow, this is actually really slow. The next one is Python bindings are almost always behind, if they even exist. So first of all, since nothing's native and nothing's supported in the mainline projects, let's say there's some sort of update to MapReduce, right? The Python project then is like, oh, wow, they made an update to MapReduce, let's go fix it. And then they take a few months to do that, right? So they're almost like always a step behind the trunks of the main projects. The next one is that nothing here is officially sanctioned. So these Python projects, Python and Hadoop, they're like almost always in some random guy's GitHub repo. Like, so the line I have here is that like I'll clone a repo and just hope that it works. Like, okay, it compiled. Okay, great. Like step one. Okay, I got it compiled, and then actually seeing it work on my actual Hadoop cluster is like another feat, right? I would say typically I might have to do on the order of 1 to 5 lines of code change in some of these projects, even the more popular ones, to get it to work in my current environment. So the fact that these things aren't, there's not like a Cloudera or Hortonworks behind the scenes that's integration, testing, all this stuff. There's a little bit of onus that's put on the user, and that's kind of unfortunate. So I'm going to go through some of so now that I've kind of talked about like why you should probably be doing this or not doing this, I'm going to go over some of the projects pretty quickly, just kind of as an overview. So the first one is mrjob. I originally called it mrjob, but then somebody called it mrjob, and I thought that was pretty cool. So I'm going to keep doing that. And what this allows you to do is it allows you to write MapReduce jobs in Python, pretty straightforward. It was open source and maintained still by Yelp. Yelp has actually done a lot of cool open source stuff and a lot of Python stuff, so I'm a big fan of theirs. And basically what it does is it wraps Hadoop streaming. So Hadoop streaming is this interface where you can pass in arbitrary scripts that take in and standard out, and then write MapReduce jobs. So what it does is it wraps Hadoop streaming and kind of removes some of the quirks of it, and allows you to write these very succinct like MapReduce jobs. So in this case here, I have word count, because what else would I show you guys? I have the mapper and I have the reducer, which in a Java MapReduce sense should look pretty familiar, except that the code is really, really short, right? I have a class, I have mapper, reducer. They're Python functions. Notice that I have no types. That's kind of where the type safety problems come in. Yeah. mrjob is fantastic. This is what I use mostly for my MapReduce jobs. There's another one called PyDupe as well, which basically does the same thing, but it's implemented in a different way. This uses Hadoop's C++ pipes, which should be faster than streaming, but I've never seen anybody really do a big comparison between PyDupe and mrjob, so I'm not really sure which one's better. But from a feature set perspective, they seem pretty good. Like they both handle similar things. So I would say like just pick one and see which one you like better. They seem pretty similar. This is from a blog post from Cloudera that was published a little bit too long ago in 2013 that did an overview of some of the major Python projects. If you Google for like Python MapReduce or something, this blog post is one of the first hits. And what this slide says is basically they gave performance numbers on the different Python Hadoop projects. What you'll see is that the way you read this is that darker red is very bad and green is okay. So what you'll see is in streaming that streaming is not that much slower. So streaming is the one where you can pass an arbitrary standard in, standard out. At worst in this case, it was like 1.7-ish slower, so worst case like 2x. When you look at my favorite guy, Mr. Job over here, in the job runtime, which is in the bottom, that was 7.3 times slower than MapReduce. To say this a little bit, there was some pretty naive way that they did serialization in Mr. Job back when this benchmark was ran, and they've since have improved it. So I would still say it's faster than 7.3x, but it's still probably significantly slower. So if you care about that my MapReduce job is taking 12 minutes instead of 3 or 12 minutes instead of 6 or something like that, then maybe this isn't the right approach for you. They have Dumbo and Hadoop in here as well, which are both projects that are still on GitHub but haven't seen a commit in over 6 to 12 months. So there are some other options out there that have kind of died off in the meantime. The next project I want to talk to you about is Pig, which is, I don't know, maybe surprising, but I really like Pig in general. And also I like Pig a lot because of a lot of the same reasons that I talked about with Python. So Pig is interpreted in a sense. I can edit it in place. Maintaining it is easier, it's succinct. So Pig is almost like, in a lot of senses, the Python to MapReduce already. And then with Python UDFs, I can use the power of Python with Pig. So typically what I'll do, actually Pig with Python is probably one of my favorite combinations that I use a lot. And what it allows me to do is I write the kind of large-scale data flow stuff in my Pig job, and then I'll have the data manipulation, data analysis stuff in Python that's attached to it. And so here, for example, there's a Pig script here on the left, and then I have 2 sample UDFs here on the right. There's nothing really surprising here. The UDFs just take in a parameter, return something. It has the notions of bags. Bags in Python are translated to a list. Tuples are tuples in Python. And then you can return strings and integers and things like that. I'm just a big fan of this. The one thing to really note, though, is that in Pig here, there's 2 ways to write Python UDFs. There's one using Jython and one using CPython. So, and this is an important thing to note if you're using a Python and Hadoop library, is what kind of Python is it using underneath. So Jython is the Python interpreter written in Java, which allows you to run Python scripts inside of the JVM. Now that's great because it's generally faster. It's running inside of the JVM, there's no IPC, it's just all running in there. The downside is that the Jython stuff can't leverage a lot of the underlying C functionality that the mainline CPython interpreter has. So the bad thing that happens there is that you basically throw out NumPy, SciPy, and all the machine learning libraries and all those libraries I listed earlier. So I'll use Jython if I'm just doing string manipulation, things like that, but if I'm trying to call out to NLTK or scikit-learn or something like that, then I use the CPython one, which is a little bit slower. Because what the CPython one does is it starts up a Python interpreter outside of the JVM, funnels the data to the interpreter, and then brings it back, which is just slow from an operation standpoint. But it's cool that I have the ability to do both. The next project I want to talk about is snakebite. So snakebite was open source out of Spotify. And the reason why so snakebite is like an HDFS client. And the reason why the Spotify guys built this was actually quite interesting. They had this workflow pipeline thing that had lots of operations per second on the name node. And their bottleneck was JVM startup time. So they would do Hadoop FSLS, JVM starts up, they do the LS, it tears down. There's ways to solve that problem, but what they ended up doing was they ended up doing like a native protobuf, I think it's protobuf, to communicate with HDFS and bring the information back. The downside is that reverse engineering the protocol to communicate with HDFS, it ended up being actually really hard. So pretty much all they support is name node ops, like LS, move, things like that. And they support reading from files, but you can't write files yet with snakebite. And I don't know if they'll ever get there. But snakebite's really cool. For example, if I write a Mr. Job that's doing some MapReduce stuff, and then I have to move around some files after it, or maybe I need to open up a file and run it through scikit-learn or something like that, snakebite's pretty good at that. The next one is interaction with HBASE. So there's 2 projects out there called Starbase and HappyBase. Both of them use the HBASE thrift gateway, which is incredibly slow because instead of going directly to the region servers, it's getting funneled through this gateway. I mean, the gateway has merits for a number of reasons, but it is slower. But unfortunately for both of these guys, the last commits were about 6 months ago, and even 6 months ago when the last commit happened, they didn't really work that well anyways. So I think in general, I think Python plus HBASE kind of lost momentum, and I don't really know anybody that's working on this. So one time I was giving a talk, somebody got really mad. It was like, wow, well, this would be really cool for me. It was like, okay, well, submit some pull requests, I guess. So yeah. The next one is PySpark. So I'm really happy about PySpark. So the Spark guys, I don't know, hopefully you've heard about Spark at this point, but if not, then Spark is like an alternative to MapReduce where I store these data in these resilient distributed data sets that are in memory, and then I can manipulate these RDDs in memory. And the PySpark or the Spark guys have pretty good interfaces in Java, Scala, and Python. And the Python stuff fell behind for a little bit, but then they started catching up, which is great. So here's like a PySpark example of word count. It's a little bit more verbose than the mrjob stuff, but it's pretty concise, and it's a little bit higher level than MapReduce. So in general, big fan. I'm really happy that the Spark guys are keeping up with the Python interfaces. So this is a great way to interact with your Hadoop data as well. So I wanted to have some closing thoughts, especially if there's anybody in here that's like a vendor or somebody that has money that they're pumping into open source. So I talked a little bit about the projects that are here, and I talked a lot about the downfalls of these things, and hopefully you're not too scared at this point, because I think there's some projects out there, that are maintained from different people, and they're in different places, but there's a lot of work to do. And so now this part of the talk is where I've tried to convince you guys that this is important and that maybe some of you should start working on it. So this one is a screenshot from the GitHub repo for Cassandra's Python driver. And if you look, these are the number of commits, and there's a lot. And the other thing that I want to point out is that the top 4 committers and then additional past that are DataStax employees. So the Cassandra guys are paying their employees to develop the Python driver, okay? And that's important because now Cassandra can have all these Python people want to use Cassandra, right? So if a Python guy sitting there is like, hey, I want a big table-like thing, and they look at Cassandra and they look at HBASE, I mean, I think my decision is pretty easy, right? Let's look at another one. Let's look at MongoDB. So MongoDB has been working on their Python driver since 2009. They really started ramping up in 2011, right? So again, and also too, the other thing to point out, the top committers are from the MongoDB company. So these aren't just like random guys. Like for mrjob, for example, the top committers are Yelp guys, okay? And I love those guys. They're doing God's work, right? But at the end of the day, like some money needs to be pumped into this thing. So I think to kind of try to motivate the Hadoop crowd here to say that this is important and maybe should get focused on a little bit is that my Python on Hadoop tutorial at the PyCon conference was sold out. And there was a lot of interest. I generated a lot of interest on it. And if the Hadoop community did a little bit of better job interacting with the Python community, there's going to be a ton of new people coming into this field. I don't know, maybe that's bad for me as a consultant, but in general, like now that we're moving into just writing data pipelines and stuff, and people are trying to do data science on Hadoop and all that good stuff, this is really important. Python has a lot of momentum, and if we can just carry some of the momentum, it'd be really good for the Hadoop community. So I hate cloning random things on GitHub and hoping they compile. I hate that some of my customers that I'm recommending using Python can't call their support vendor and get help with it. And also, too, these people are just making random APIs and things like that and aren't able to, the ecosystem is not very cohesive. So that's my kind of call to action for somebody in here to actually to help out with this. All right, so that's all I got. I'll be happy to take questions for the next 5 minutes or so. Thanks, guys.
What about a client for Hive from Python? Do you know any good ones?
So in Python, you can use Hive UDF, you can write Python UDFs in Hive, right? I believe.
The other way around, just calling Hive SQL from
Calling Hive SQL from Python.
yeah.
Does anybody have an answer to that? I've never tried. Okay, PyHive library? Okay. I'm actually going to check that out. PyHS2? Okay. So it has Presto support. I'm repeating so that it gets recorded. Okay. Cool. Thanks. Yep.
Yeah, I just wanted to add a follow-up to that. So PyHS2, the guy posted on GitHub yesterday that he's retiring his maintenance of that project. So if anyone wants to take that over, it'd be great. I mean, I'm going to look into it because we're starting to use it.
Okay.
So
Thank you.
relevant. Yeah.
All right. Any other questions? All right. Thanks, everybody. I'll stick around for a few minutes. Thanks.